Hello, good morning students. Myself Ranjan Chowdhary, PGT Physics teacher at the public school. So, in last video, we have discussed about the KVL, KCL and Wheatstone bridge, right? In Wheatstone bridge, we have seen there are 4 resistance, that is 4R, which consists of 4 resistance, and in balance condition, no current is flowing, then P by Q equal to R by S. On the principle of Wheatstone bridge only, we study, or there is a bridge named meter bridge. Meter bridge is generally used to find out the value of unknown resistance. It is a device used to find out the value of unknown resistance, and its principle is based on the principle of Wheatstone bridge. Right? Based on Wheatstone bridge, right? It consists of 1 meter wire. See, wire is A and C, made of constant and or manganese, right? And it is placed on a wooden block, right? And there is a scale. That is, there is a scale running parallel to the your wire. Scale placed parallel to the wire, right? See here. Here we will connect the resistance box of different values. Here we will place the unknown resistance. At point D we will connect a galvanometer, and through galvanometer we will connect a jockey, and we will slide it. Now see working. Also there is a EMF E connected through a key. Now when we will close the key and when we will slide this jockey over the wire, then at some point, that is, let us say at point B, this galvanometer will show no deflection. That is what we have to do. We have to close the key, then we have to slide the jockey over the wire. At point B, there will be no deflection in the galvanometer. When there is no deflection, then it is said to be meter bridge is balanced. That is, if we consider this is P, this is Q, this is R, this is S, and P by Q equal to R by S. In Wheatstone bridge, this was considered as resistance P, this is Q, here length will be considered as R, and this length 100 minus L as S. So when under the balance condition, AB is the length L and BC is the length 100 minus L, right? That is. Here, let us consider that is in resistance box, resistance is R and unknown resistance is how much X. So instead of P we can write that is R, instead of Q we write X, and we can easily see this reading L from the scale, and we can calculate the value of 100 minus L, that is unknown resistance that is we can get this R value from the resistance box, L value from the reading of the scale, and we can easily calculate the value of that is your unknown resistance, right? So point to be remembered here. See, this strip, these are copper strip. These are copper strip. Copper strip are very thick, right? That is area is more. Its width is more. Why? Because you know when area is more, then the resistance will be less. Because here we are calculating the value of resistance. So if you take very thin strip, then it will have high resistance. And in finding this resistance, it will not be given accurate value. So in order that we get the accurate value of this resistance, unknown resistance, these strips are taken more area. Area of the strips are more in order that the resistance is less. Right? Also one thing, generally we try to get the balance point at the middle of the wire, generally at the middle of the wire, not at the end of the wire. It is so because since all the resistance, here all the resistance are of approx same value, right, of the same order. So when we get balance point near the middle point, then the value of unknown resistance which we calculate will be very accurate. If we are not getting the balance point in the middle point, around the middle point, then the value we find out, it will be not accurate, right? So question is asked, why generally we try to get the balance point around the middle of the wire. It is so because so that we can calculate the value of unknown resistance accurately, right? Let us see some numericals. Yes, my question is based on meter bridge. It says that R and S means in meter bridge with R and S in the gap. Means there are two resistance R and S in the gap. That is in meter bridge R and S in the gap, the null point is found to be 40 cm from here. See, that is from 40 cm from A, that is L is equal to 40 cm and 100 minus L equal to 60. Right, so we can write that is according to first statement we can get R by S equal to 2 by 3. In second case what they say, if a resistance of 30 ohm is connected in parallel with S, means if we connect a parallel resistance of 30 ohm with the S, then the null point will be at 50 cm from A. Now see case 2. Now see, 30 ohm is connected in parallel with S. then this will become, see, the balance point shift how much? 50 centimeters. So here we get that. Next, that the parallel combination of S and 30 is S dash. That is like in the second case we get the condition R by S dash equal to S dash is what? Parallel combination of two resistance, that is 30 ohm and S. So S dash equal to S into 30 divided by S plus 30. So we get the condition R equal to S dash. This is right. What we will calculate? We will calculate the value of R and S. Now see. Right, so instead of here, can I write? That is, instead of S dash, I can write R. Also, see here. Instead of R, I can write 2S by 3. On simplification we get S equal to 15 ohm. So R equal to how much? That is, we are getting S equal to 15 ohm and R equal to 10 ohm. Right? Yes. The next question is that two resistance X and Y is taken, then see, when X and Y are there, then balance point is there. So here we can write X by Y equal to 40 by 60. On simplification we get X by Y to 2 by 3, that is X equal to 2 by 3, Y equal to 3 by 2X. First condition. In second condition they are saying if there is a series resistance connected with X, okay, if there is a series resistance connected with X, that is, let us say it is Z, then resistance will be X plus Z and divide by Y, then balance point shifts 10 centimeters. That is, it becomes 50, 100 minus 7, 50. That is X plus Z equal to Y. Right? Now see, instead of X we can write 2 by 3Y. That is, we are getting Y is equal to 3Z, or that is X by 2 is equal to Z, or Y equal to 3Z, that is X equal to 3Z. Third condition they are saying, now if this resistance, Z resistance is used in series with Y, then the balance point shift you have to find out that balance point. Same resistance, that is, this resistance is now to be connected in series with Y. That is, the balance point will be L, then 100 minus L. Instead of X, get it X. Now put the value of Y in terms of X. Now put the value of J in terms of X. J is equal to X by 2. Just we have put numerator and denominator in terms of x, so that x will be cancelled, and just we have taken, that is, we have taken the LCM, and solving we are getting L is equal to 33.33 centimeter. Right.